Before the first planet spun into existence, before the oceans filled our world, before life itself even had a name, there was hydrogen. The first element, the simplest element, and by far the most abundant substance in the entire universe. And now, this ancient element might just hold the key to our future. Hydrogen was born in the fiery moments right after the Big Bang. As the young universe expanded and cooled, the very first atoms began to form, and those atoms were hydrogen. They became the fundamental building blocks for everything that followed: the stars, the galaxies, and eventually, life as we know it. Deep inside the core of every star, hydrogen atoms are crushed together, fusing into helium and releasing unimaginable amounts of energy. This is the same nuclear fusion that powers our own sun, the source of almost all energy here on Earth. Yet, for nearly all of human history, hydrogen remained a ghost. It was all around us, but we had no idea it was even there. Then, in the 16th century, scientists started noticing something strange. When they mixed certain metals with acids, a mysterious gas would escape. It was incredibly light, completely invisible, and as they soon discovered, highly flammable. It wasn't until 1766 that the English scientist Henry Cavendish finally isolated and studied this gas, which he fittingly named flammable air. Cavendish made another incredible discovery. When this gas burned, the only thing it produced was pure water. A few years later, the French chemist Antoine Lavoisier gave the element its modern name, hydrogen, a word that literally means water former. For the very first time, humanity had finally put a name to one of nature's most essential ingredients. By the 19th century, this newfound element was ready for its first major application. Because hydrogen is the lightest substance known to man, it was perfect for lifting things into the sky. Entire cities would gather to watch in amazement as enormous hydrogen-filled balloons floated gracefully above the earth. This led to the era of the Zeppelins, massive, rigid airships that could cross oceans. But then came 1937. The world watched in horror as the Hindenburg airship burst into a ball of fire over New Jersey. The disaster was a turning point. Hydrogen became synonymous with danger. Fascination turned to fear. And for decades, the world turned its back on the potential of hydrogen. But hydrogen was destined for a comeback, not in our skies, but far beyond them. In the mid-20th century, the space race demanded fuels with more power than anything used before. Liquid hydrogen was the answer. NASA harnessed its incredible energy to launch the mighty Saturn V rocket, the machine that carried humans to the moon. But that wasn't all. On board the spacecraft, hydrogen fuel cells were quietly generating electricity to power the ship's systems, and as a bonus, producing pure drinking water for the astronauts. In the vacuum of space, hydrogen proved it was more than just flammable air. It was powerful, it was efficient, and it was clean. This brings us to a crucial point. Hydrogen isn't a fuel in the same way as coal or oil. You don't just dig it out of the ground. It's what we call an energy carrier. This means we first have to use energy to produce the hydrogen, which we can then store and use later to release that energy. The amazing part is that when hydrogen is used in a fuel cell, it reacts with oxygen, and the only thing that comes out is water. No smoke, no carbon dioxide, no pollution. The real question then is, how do we make the hydrogen in the first place? For a long time, most hydrogen was produced using fossil fuels like natural gas. This method creates what we now call gray hydrogen. It's relatively cheap, but it releases a lot of carbon dioxide into the atmosphere. An improvement on this is blue hydrogen, where the carbon emissions from production are captured and stored underground. But the real game changer, the ultimate goal, is green hydrogen. Green hydrogen is made by a process called electrolysis, which uses renewable electricity from sources like wind, solar, or hydropower to split water molecules into hydrogen and oxygen. This process creates zero emissions. It's a completely clean cycle and represents a new, sustainable chapter in our energy story. So, how does hydrogen actually generate energy for us to use? There are two main ways. The first is through fuel cells. A fuel cell is like a battery that never runs out as long as you keep supplying it with hydrogen. Inside, it combines hydrogen and oxygen in a chemical reaction that produces electricity directly. Fuel cells are silent, highly efficient, and their only emission is water vapor. They're already being used to power cars, buses, trains, and even provide backup power for entire buildings and data centers. The second method is hydrogen combustion. You can simply burn hydrogen to produce heat, just like natural gas. This is perfect for heavy industries like steel and cement manufacturing, or for power plants that need intense heat processes that are very difficult to decarbonize using only electricity. Transportation is one of the biggest sources of emissions worldwide, and hydrogen offers a compelling alternative. Imagine a world where heavy-duty trucks, buses, and trains can refuel in minutes, travel long distances just like their diesel counterparts, and emit nothing but water from their tailpipes. This isn't science fiction. It's happening today. Hydrogen-powered buses are already operating in cities around the world, and heavy trucks are being tested for long-haul freight. Looking ahead, hydrogen could even power the ships and aircraft of the future, creating a truly clean global logistics network. Some of our most important industries like steel and chemical production are also our biggest polluters. These sectors rely on extreme heat from burning coal and gas, and you can't just plug a blast furnace into an electrical outlet. This is where hydrogen shines. Green hydrogen can replace coal in the steel-making process, creating what's known as green steel with zero carbon emissions. Applying this technology across heavy industry could eliminate billions of tons of CO from our atmosphere each year. Renewable energy from wind and solar is fantastic, but it has one big weakness: it's intermittent. The sun doesn't always shine, and the wind doesn't always blow. What do you do when you're generating more power than you need? And how do you keep the lights on when renewables aren't available? Hydrogen solves this problem. Excess electricity from a sunny or windy day can be used to create green hydrogen. This hydrogen can then be stored in large tanks for weeks or even months. When power is needed later, the hydrogen can be converted back into electricity using a fuel cell or a turbine. It acts as a massive long-term battery for the entire grid, bridging the gap and making a 100% renewable system truly reliable. Now, hydrogen isn't a perfect silver bullet. It faces real challenges. Producing green hydrogen is still expensive. Storing a lightweight gas safely and compactly is technically difficult. And building a whole new infrastructure of pipelines and refueling stations will require massive investment. But think about it, every major energy revolution in history started this way. Oil was once difficult to extract, and the first electrical grids were incredibly expensive and limited. With innovation and scale, these challenges can be overcome. From the first moments after the Big Bang to the engines that will power our future, hydrogen has always been with us. Now we are finally learning how to harness its power cleanly and wisely. Hydrogen won't replace every other energy source overnight, but it will power the things that electricity can't. It will store energy when other methods fall short, and it will help clean up the industries that once seemed impossible to decarbonize. The future of energy might be invisible. It might be silent, and it might fall as gently as water vapor into the air. We are entering the age of hydrogen. Thanks for watching. If you found this journey through the past, present, and future of hydrogen interesting, don't forget to like this video and subscribe for more deep dives into the science and technology that will shape our world. See you next time.